Okay, so even though we can hit our enemy and they do clearly go to the hit state where their movement stops, we do need to apply the actual knockback force vector for a period of time to our enemies so that they have a proper knockback. So the knockback direction should be in basically the direction that they got hit. So if the projectile comes from the right and it hits them on the left over here, then it should push them leftwards. Or at least that's how I want to try setting it up initially. So in our hurt box, we were already taking the hit data and passing that through the wasHit signal, which the Blackboard setter is using on wasHit to set the hit data into the Blackboard as well. So once it's in the Blackboard, we can just read it from PlayHit. And you can see on before run, we're already getting the value of the hit data and storing that inside of our script. So our hit data, if we right click here and check lookup symbol, has already been set up to have a knockback. So the knockback stats, as we covered in the previous videos, has a force and duration, and we might add more stuff to that. For instance, we would want a hit direction. For instance, we would want a hit direction, but that doesn't really go in the resource for the knockback stats. That would be more of a runtime property that will include the knockback stats of the knockback itself, but it will also be set up with the runtime property taking the direction between the hit box and the hurt box and setting that as the knockback direction. So we're going to need another class that will just include the knockback stats inside of it. So if I open up the weapons folder, we have knockback stats down here. Let's right click on weapons and do a new script. I'll call it knockback. And this will be of type object. So it'll basically be a runtime object that will have a reference to the knockback stats. So let's create that and open that up. I'll give it the class name knockback. And we may want to define an initialize function. So I'll do function underscore init. And inside of here, we'll put in some parameters. So we're going to have p direction, which is going to be a vector2, and then we'll have the p knockback stats, which is of type knockback stats. So when we bring in the knockback stats, we want to set the reference in here. So var knockback stats of type knockback stats, and we'll also save the direction. So var direction of type vector2. And you know what, actually the stats here, I'm going to remove the knockback. That's kind of redundant. So it'll just be stats knockback stats. The class name's already knockback, so it's kind of implied knockback dot stats. So let's go down here to the init function and we'll say direction equals p direction. So just taking the parameters and saving that inside the object properties. And then we'll have stats equals p knockback stats. I'm okay with leaving the name here, p knockback stats here. Since this is only used in this function, we want to be very clear about what kind of class this is. I think that's okay, but you could also do p stats if you wanted to. Either works just fine. Okay, so we have our knockback instance, and we want to create that on hit. So if we open up our hit data script, you could just click over here to open it if it's not. So in our hit data.gd script, when we pass in the knockback stats, we want to calculate the direction between the hit box and the hurt box and use that for creating our knockback. So the knockback here is going to be type knockback. And then in order to create that, I'll say knockback equals knockback.new. And we need to give it the direction between the hit box and the hurt box and the knockback stats. So I'll say hit direction and then p knockback stats, or let's say p stats here. P stats. And then let's come up here to p knockback and make that p knockback stats. Okay. And then we don't need this line at the bottom. So to get the hit direction, we need to do hitbox dot position or global position dot direction to hurtbox dot global position. Okay, and that should pretty much be that. So in our init function, which we are requiring these to create, and it's an object, so it'll only ever be created by doing like hit data.new. We also create the knockback inside of here. So this means we need to update our other scripts possibly. Let's check the Blackboard setter. So we're setting the hit data, and then we come in here to the PlayHitAction. Okay, so there's one more thing though. We only want there to really be a knockback if the knockback stats is valid for creating a knockback. So we'll say if p knockback stats, then we'll create the knockback. So basically, only if we pass in the knockback stats, we'll create a knockback from those stats. Otherwise, the knockback is still going to be null, which means that if we go into the hit has knockback condition, it's only going to succeed this if the knockback is created. So we go on from there to the play hit action, and we're going to have access to that knockback now. So rather than checking now hit data knockback duration, we'll just check if there is a knockback. Then we're going to play the animation and all of this. And what we'll do is we'll take the actor node and set its velocity to the knockback direction times the speed of the knockback, which will make a property up here for that. And then after run, we'll just set the movement to 0. And I think that should be good for now. Okay, so up here we want to say at export var knockback speed. And this can be a float. We'll set it to, let's say, 25.0 by default. So when we are running the play hit action, we do want to verify that the actor is a CharacterBody2D. Movement would work pretty differently if we're using a rigid body 2D. So this action really only applies to characters. So let's get a reference to the character or the CharacterBody2D, and we'll do that before run. So character equals p actor as CharacterBody2D, and if character, or let's say if character equals null, push error. So we'll get the character reference from the actor. If that doesn't show up, then we know it's not a CharacterBody2D, which is problematic because this knockback depends on it being a CharacterBody2D. So that would be an issue. And so basically after that, we assume that the character is a CharacterBody2D. And that means that we can go down here and say character.velocity equals, okay, so now we need to get the hit data. So hit data.knockback.direction. And now that I think about it, in the knockback stats, there's a force which we can use here for the velocity. So instead of knockback speed up here, why don't we make it more like knockback multiplier? Knockback multiplier. And this will be 1.0 by default. We can make it a export range, let's say 0, 1, 0.02. And that can be or greater. So we don't want it to be less than 0, or do we? I guess I could see a situation where you might actually make them knockback negative. So I'll remove the or greater there. We click on play hit action and we can see our knockback multiply kind of defaults to or greater. So we can't actually set negative value there unless we do this. Hide slider or less. Maybe we try hide slider. Okay, and we can't really control that. So I'll just do export var. Yeah, okay. That means that you can do like negative 0.2 in there if you want to reverse the direction of the knockback, which would be pretty weird, but it's an option. So for our character velocity, we get the knockback direction, and then we want to multiply that by the force. But that would apply to every instance of a knockback. So I think actually doing a little calculation like this would make more sense on the knockback script. So I'll go into knockback, and then let's have a function called getForceVector, which is going to return a vector 2. And this will have var force vector, which is going to be equal to the direction times stats.force. And then we're going to return that. Okay, so now we never need to manually make that calculation again. We can just take getForceVector in the play hit action, and we do it like this. Hit data.knockback.getForceVector. And then we times that by our knockback multiplier. Okay, so basically in this component, we get the direction times the force, but we might want to be able to control how fast the knockback is on a character by character basis. So we also add in the knockback multiplier. So if you want to, say, have like a really sturdy character that reduces knockback by 90%, you would just take the knockback multiplier and make it 0.1, and now the character is 90% resistant to knockback. Yeah, entirely possible that you might move this out to like a character stats script. And maybe that does make some sense actually, because it is kind of a stat of the character. And there might be more than one action where you play the knockback. So let me think about that. So let me think about that. I guess we can have a reference to the character stats. So character stats, or you know what, knockback can be in object stats. So we have our object stats reference, the resource from previous videos. I'll move into here and let's call it knockback multiplier. Yep. Okay, so now in the PlayHitAction, we'll do object stats.knockback multiplier. Okay, so now we can just reuse the knockback multiplier just by referencing the object stats. If we go into the PlayHitAction, we can quick load our invader stats, which is going to have the knockback multiplier inside of here. So we can customize how resistant the invader is to knockbacks just by setting this. And this property will exist on all object stats, which I would assume you would have one per interactable object in the game. Okay, so that sets our initial velocity. We want to stop it after the run, so that will be just character.velocity equals vector2.0, and we just set that after run. So let's hit play and see if this works at all yet. So I'll hit this guy. Let's see, the hit timer.start, knockback.duration. Okay, so it's now knockback.stats.duration. Okay, and let's rerun the scene. I'll hit a guy. And I'm not sure if that is actually going or not. So we could do prints character.velocity right here. I'll also set a breakpoint. We'll hit play and see if that's anything that's not 0. Okay, so we have the character, and then we have the velocity on that, which is actually hard to read from the inspector. So I will hit play and we'll see what that was set to. Down here, we can see that there is a force, but it's not exactly moving it that fast. So we probably need to bump up the default force on the projectile. So if we go into the hitbox 2D, we have the weapon stats. So we want to go into that. So we have our knockback stats, which I might actually rename knockback stats now because there is a knockback class. So we do have to be very specific there now. And then in knockback stats, we have the force. I'll just default that to 300. Now I know the reference to the knockback stats is going to break somewhere. So I'll hit play and let's see where that is. So here we're looking for weapon stats stat knockback, but what we actually want is knockback stats. So we hit play again. Let's shoot a guy. Okay, so what happened there? They never exit the state. Okay, we can also see that we're using a reference to the weapon damage and the knockback stats here, but it would probably be better if we just did weapon stats, save ourselves a parameter. Let's jump into hit data. Inside of hit data, I'm gonna make it just weapon stats. Okay, so P weapon stats. So the amount will be equal to P weapon stats dot damage, and the knockback is going to be equal to P weapon stats dot knockback stats. And then for here, we're going to check P weapon stats dot knockback stats. And down here, we'll do kind of the same thing, P weapon stats dot knockback stats for creating the knockback from the weapon. And yeah, all of that reduces us a parameter because the weapon will already have the knockback and the damage inside of it. So any other parameters we need from the weapon stats, we can just pull them in here like that. Okay, so if I set a breakpoint here and I hit play, we'll see what the issue is. So we come down in here to the weapon stats of the projectile, and we can see there's no knockback stats here. So that means that the knockback's not going to be created. But we can see that it's also problematic because our character gets hit, but the hit data still persists on the character. So because of that, it never actually goes to the wander state again. So we do need to fix that. Okay, and I guess what we need to do for that is if there's no knockback, then we just need to remove the hit data immediately. So let's see, if is playing is false. Let's see what's going on here. So I'm going to set one for here. If there's no knockback, it should do is playing is false, which should make after run go here, which removes the hit data. But let's see what's happening. So I'll shoot, and we never get there. That's probably because on the hit has knockback condition, we never that we only pass if the hit data has a knockback, but we never remove it otherwise. So I'm thinking it's probably better to just check the hit condition like we originally did and not have this hit has knockback condition unless we're going to also remove the hit. But if we're doing that, it doesn't make much sense as a condition. So let's find the hit condition, and I'll add that in. Right click is hit condition. That'll be the top, and then hit has knockback. We'll remove that both from the project and from here because that no longer makes sense. I'll check the is hit condition. All we're doing is checking that there's hit data. And then in the PlayHitAction, we're still removing the hit data, regardless of whether there's a knockback or not. So let's hit play. We shoot. Okay, now we actually do get to the before run. We'll see that we have no knockback. So therefore, we get to is playing is false, which means that the blackboard is going to remove the hit data from the character. And as a result, he should be able to move again. Okay, so yeah, bugs like that you've got to watch out for. Okay, now that that's working, we can set the weapon stats. So weapon stats basic, we wanted to recreate the knockback stats, so just new knockback stats. We'll use the defaults, 0.1 duration, 300 force. Okay, so if we hit play and we shoot a few times, then we'll see there's a little bit of a knockback, but it kind of doesn't work as consistently as you might think. I believe that's due to the physics of the grounded motion mode CharacterBody2D. So one thing we could do is uncheck block on wall, which would allow it to slide on walls like the floor. And if I shoot now, that looks a little bit more consistent. Another thing we can just do is check if when we hit the character and we're creating the knockback direction, if the character's on the ground, and maybe in grounded mode too. And then if that's the case, then we just ignore the Y component and just do a left-right knockback. So in our hit data, maybe we do need the reference to the physics object. So I will make that an extra parameter here. So p hit. So we could put up here maybe p game object, which is going to be a physics body 2D, or game body, object body, or we could just say physics body. Yep. Okay, that makes more sense. Okay, so the body is going to be equal to the p physics body, and we'll put that in here. So we need the main physics body of the object that was hit. We're passing that in there so that we can check if it's on the ground for creating the knockback. So I suppose we want to put that physics body into the knockback as well. That way we can have the knockback calculate whether it should be pushing left or right internally, and then we'll use that when we get the force vector back. So let's pass in the body, the hit direction, and the knockback stats. Yep, okay, and let's go into knockback. So I have the p physics body, which is a physics body 2D. We'll save a reference to the hit body. Okay, so just like before, we'll put the body in there. Body equals p physics body. That should really be first. And we should be having a force vector property, I think, too. So we'll say var force vector, vector 2, and we'll calculate that. So let's rename this to be calculate force vector. We'll call that on init. So force vector equals calculate force vector. Okay, and then now, basically after having this stuff set up, we already have this. We don't need to calculate the force vector from outside of the knockback. We just need to read from it. And then down here, we can adjust for the fact that the physics body is on the ground. Okay, so if body dot is on ground, is that going to work? Okay, we'll say if body is character body 2D and body is on ground. So if the body is a CharacterBody2D and body.is on floor, then we're going to adjust the force vector by removing the y component of it. So the force vector dot y is going to be equal to 0. We'll try that for now. Another option would be to change the direction to only have left, right. But we can see how that works. So let's hit play. Of course, we didn't add the physics body for the hitbox. So the hitbox should have a reference to the hittable object. So let's look that up. Okay, in the hitbox, let's do export var body, CharacterBody2D. And we should assign that in the invader. So if we go down to hitbox, we assign the reference to the invader CharacterBody2D. So we can pass that into our knockback scripts. Okay, so the hitbox is going to get the hitbox.body. It's going to get itself. It's going to get the hitbox itself. Oh, well, you know what? The hitbox has a reference to the body, so we actually don't need that parameter. Let's remove that. Let's jump into hit data. Right click, look up symbol. Since the hitbox has a reference to the body, we can just remove this. And then we can just do p_hitbox.body down here. And we don't need to reference that. We don't need this as well. Okay, so we're just doing the hitbox and the hitbox. The hitbox already has the body and the weapon stats. Okay, so now we just need to make sure whenever you use a hitbox that you do reference the body, which in this case is the invader, the root node of our invader scene. Okay, we hit play. Let's see how it works now, if at all. Yeah, so there's no get force vector now. It's calculate force vector. So we want to just do knockback dot force vector because we calculate it on init, so there's no need. And then we can hit play. We shoot, and we should get a knockback on both. We can see that the Y component is set to 0. So very much the knockback depends on if we're hitting straight on or not. So I don't think that's quite what we want. This simple way in knockback would just be to make the direction left or right if they're on the ground. So we could say var adjusted direction equals direction. And then let's move this up here. So if the character is body 2D and on the floor, then we're going to make the adjusted direction just left or right. Then we're just going to make the adjusted direction left or right. So we'll get the sign of the direction. Direction.x.sign. So far, sign x is equal to the sign of the direction.x. If sign x is greater than 0. Basically, it's 1. We could say equals 1. Then we're moving it to the right. So adjusted direction equals vector2 dot right. Else if sin x equals -1, then the adjusted direction is going to be vector2 dot left. And then the third case is that the direction x is 0, so we'll just keep it as 0, so we don't need to do anything there. So now we use the adjusted direction instead of the original direction. I know a lot of extra steps here. So one option you can go with is that you just have all your characters be rigid body 2Ds in your game. If you just want to just directly apply a force vector and you don't need to do any of these manual movement adjustments, then that is one advantage of doing rigid body 2Ds. Okay, so if we hit play now, we can see we hit the characters. They're going to get the full knockback, but the direction is still not quite right. And I think that could just be that at the moment of calculation, the hurtbox and hitbox positions are not quite what we would expect them to be. So what I might do is calculate the direction from the character body 2D, the one that we're hitting. Even though we hit the hurtbox, the direction would be based on where the physics body 2D is. So let's go to, where would it be? In hitbox, I think. Okay, and we create the hit data. So what we might want is getting the hurtbox.body.global position. It might make more sense. I mean, it is the physics body after all, so that's really the position that matters. So let's give it a shot. And I'll fire a couple shots here. So far, so good. Yeah, all right. That might be more what we want. That's looking good. So given that we kind of fixed that body issue, maybe we don't need to recalculate this here. So maybe it was just because of the bad positioning on the calculations. I will comment this out for now because that could still be useful, but let's see how this goes. Fire, we shoot again down here. And yeah, the thing is that based on the direction, it might be mostly going towards the floor still. We can see in the output the direction of these vectors. So you can see that like when it hits from above, we get only 8 force magnitude to the left right, but 300 from up down. And because it's hitting the ground or colliding with the ground, it barely moves at all. That's why it's like that when it's on the ground. In that case, maybe it is best to have this here so that a knockback on the ground just slides against the ground every time and it's consistent. So now it's like this. The only thing we kind of got to change is that the knockback is too much, I would say. So if we go to weapon stats, knockback stats, let's change this default to 100. I'll hit play because that's going to update the basic projectile. Oh, I guess it didn't actually. Let's open up weapon stats basic and, oh, I should. Set that to 100. Let's reboot the project. So I'll hit play again. Let's shoot here. Okay, is the knockback a little better? I would say it's like still too much. Oh, I see. For some reason that is defaulting to 300. Do I have 2 copies of weapon set basics? No, I don't. Okay, it was just set to a higher value for some reason. Okay, so let's shoot. Yep, we get that short knockback. It's very little though, so I might actually increase the duration. I might want to increase the default duration as well too. So we make it 0.25 at 100 force units per second or something like that. So we have a hits. So in weapon sets basic, let's set that to the value we want to use. But I don't think it's actually using the duration properly. Let me set that to 1 second, and then we'll hit play, we'll try again. So we have our, okay, it is actually using the duration. So 0.2 or 0.25 seconds. We hit them. So I kind of see now, when we hit them, it's like they are kind of wandering the other direction. So it's actually not that clear that the knockback is working, but if you look at the animation frames, it is playing the knockback for that 0.25 seconds. And it is going the right direction that we would expect now. So the knockback for the CharacterBody2Ds is working. So I think what we need to do next is give more of a visual effect to when the characters are knocked back. Just in case the speed is too consistent with the base movement speed, it's a little hard to tell. So for instance, we could just turn the character red or flashing red with a shader when the character gets hit. So that's kind of what we'll work on in the next video, kind of getting the knockback hits to kind of wrap themselves up here.